Hello folks, so in this video we're going to talk about how we can use an exponential function to model a situation, and then we're going to see how we can use logarithms to actually solve this problem. So the problem we're looking at is that your car, so a typical car loses about, we'll say, 30% of its trade-in value every year. And we're just going to suppose that your car is currently valued at $5,000. Question, assuming your car loses its value continuously, meaning it's always slowly losing value, when is your car going to be worth $2,000? Okay, so the first thing that I would do here is to create a function. And we know that because it's losing about 30% of its value, losing 30% is the same as saying keeping 70%. So you keep 70%. And the way to model this is to say, well, if I want to keep 70% of something, the way I calculate that 70% is to multiply it by 0.7. So I'll go times, times 0.7. And so if this is the current value, we can start our time, or independent variable, from now. So what I mean by that is I'm going to say at y, again, y is the value, after, I'm going to say t for years. Well, we'll just use x. After x years. Now, since we are going to always be keeping 70% year after year, then we know that this pattern grows exponentially because it's always multiplying by 0.7 every year. If that's the case, then we're going to have an equation like this: $5,000, yeah, times 0.7. That was very ugly, I apologize. Times 0.7 to the x power. Okay, not too crazy there. That's not where I actually wanted to. I didn't want to take too much time on this one, so if you have questions, leave a comment, shoot me an email, or something like that. Again, x, let's be really clear what x is. X is equal to the number of years from now. Let's be clear. So if when I plug in x equals 0, that would correspond to the price currently, or the value currently, in which we'll get 0.7 to the 0, which is 1, and our car is worth $5,000 right now. Okay, so the question is, when is our car going to be worth $2,000? Mathematically speaking, this simply means that when is y going to be equal to 2,000? Well, if I plug this into our equation, we're going to get something like this. Not something like this, exactly this. And we need to solve for x. So this is not too bad. Well, I'll just divide both sides by 5,000. We can see clearly already I can just kind of divide both sides by 1,000 first. So on the left side, I'm going to end up with 2/5 equal to 0.7 to the x power. Okay, this is where the logarithms come in, because we have the base and we have the final answer, but we don't know what the exponent is. And that's what the logarithm tells us. The logarithm will tell us what exponent do we need to get from 0.7 to 2/5. So how could I do that? Well, there's a couple ways we could do that. One way is to use the change of base property, but in case we don't remember that, because sometimes that's just another formula to remember and you quite honestly don't need it, I could just take the logarithm of both sides. Why would I do that? Well, I'll take the logarithm, and because my calculator can only handle base 10, I'm going to use log base 10. So I'm not going to write it in, because if I don't write it in, it's implied already. That's base 10, like so. Now we go to one of our favorite properties, because one of the properties of exponents allows us to take this exponent in the argument and bring it out in front. What this new equation is going to look like then is this: log of 2/5 is equal to x times log of 0.7. And now, again, this number, this looks like a big mess, but remember, that log base 10 of 0.7 is just some number. It's going to be 7, 8, 0.5. It's just some number. And so I have x times some number. If I want to isolate x, I just need to divide by it. So I'm going to take the left and right side and divide that by this mess, log of 0.7, log of 0.7. And that is what our final answer is. Now we can actually use our calculator to evaluate this, so let's do that. So I've thrown it into my calculator, and my final answer after I run this calculation is, and I'll do 3 decimal places here, 2.569 approximately. And remember, let's not forget our units. This would say 2.569 years. Again, we could double check this by plugging it into our equation. So our equation was y equals 5,000 times 0.7 to the x power. If I plug in that, I'll get 5,000 times 0.7 raised to the 2.569. I actually don't even know what that is. Let's close that, sorry. And let's see, if I do 0.7 raised to the 2.569 times 5,000. Now, of course, this is going to be off a little bit because we rounded the final answer, but it's approximately 9999.986. Well, I guess we should round it off, so 99. And hey, that might as well be $2,000. Okay. So based on this equation, based on this scenario where a car is currently worth $5,000 and it loses 30% of its trade-in value every year, we could expect that in a little over 2.5 years, the car is going to be worth about $2,000. Hopefully that helped, and I'll see you in the next video.